On this recording. Welcome, everybody. This is E equals MC Awesome. We are the team that is going to be doing a relief valve sizing. Team members include me, myself, Patrick Hall, Enrique Sanchez, Evelyn Galvan, Lawrence Bourne, and Angel Tovar. Our mentor for this project was Mr. John Belbis, and our faculty advisor was Clarissa Belbis. Our project goals, we mainly had two, a primary and a secondary. The primary objective of this project is to size a relief valve for an ammonia accumulator at the Goodyear facility here in Pasadena off of 225. The secondary is to model the piping system around the ammonia accumulator. Our design plan, our plan for this project is to research the requirements for Wastegate 369 over here in the yellow and evaluate the needed flow rates in pounds per square inch. The attached sketch shows the customer's requirements of the ammonia accumulator as well as the equipment being protected and all piping and instrumentation equipment needed.
Our team project is to size a pressure relief valve for an ammonia accumulator. Our piping system is presented in the picture next to it for the Goodyear processing facility. Primary function of this valve will be to relieve any excess line pressure that accumulates. The line operates at a maximum pressure of 150 psi. After this amount of pressure, the relief valve will release any excess pressure that has built up.
Thank you. So now we'll be going through some scenarios. So first off, we'll go through fire and thermal expansion. External fire under and around the accumulator, assuming the fire exposure is only about 1 foot 8 inches above the bottom tangent line. So what this basically means is if you imagine a vessel standing vertically above ground, whenever there's a fire, if its fire is above 1 foot 8 inches above the tangent line, which means it's the bottom part of the vessel, the vessel is still safe without having any failures going through it. This also has a protective fireproof insulation that reduces the NFPA 30 fire heat factor. The next one we have blocked outlet, which is the worst credible case used as a basis for ERS design, which means emergency response system. This maximum pressure for the ammonia compressor sets at 195 psig, and the PSV set pressure of 150 psig as a drop through the existing ammonia control valve. This maximum flow through the ammonia control valve at relief conditions would determine the maximum venting rate. What the 195 psig also means is that's what the vessel is set at. The MAWP for that is 195, although it can go up to 300 psig for that vessel. 150 psig is for everything else that's not within the vessel itself. It's pretty much just everything outside the vessel.
Overpressure would be our third relief scenario. Vessel has a 40-gallon capacity, is 1 inch to 3/4 of an inch in diameter in a vertical position with 150 psi as its maximum allowed working pressure. ERS is designed to have a rupture disc with 142 psig set pressure under a conventional safety relief valve with 150 psig set pressure. Venting during fire will be all vapor. Venting during blocked outlet will be two-phase.
Protective measures for the rupture disc. Although rupture disc can be used as a secondary failsafe to protect the process line, a rupture disc is a barrier between the relief valve and the process, but it is definitely not a filter. The design, a rupture disc is a type of sacrificial part because it is a one-time use membrane that fails at a predetermined differential pressure, either positive or negative. The lifespan of a ruptured disc is 20 years, and after that you have to replace it. A ruptured disc will generally blow apart within positive 10% or negative 10% of the listed set pressure. So a ruptured disc with the setting of 100 psig will blow within the range of 90 or 110 psig. The ruptured disc has 3 layers, and as you can see in the image, it has 3 film layers. It has 2 film layers, and one at the very top, one at the bottom, and in between those, there is a plastic that stops the air that stops the air of going through, or whatever the chemical is that stops it from going through. And the design is prepared on purpose to control its blowout, because once it blows out, you want it to be controlled. Um, the installation. The installation is an important consideration that can affect the performance of the ruptured disc. If it is an existing installation, you do a visual inspection of the ruptured disc holder. Where it says standard holder, you would have to make sure that it's all clean before you replace the ruptured disc. Oh, ruptured disc tags with the flow's arrows must be pointing in the same direction as the flow arrows on the ruptured disc holder.
The pressure indicator uses ladder logic to regulate the pressure automatically. It sends real-time data to the PLC in the motor control room. This allows the Goodyear plant operators to regulate the allowed PSI in the line WG369. The budget plan. Due to the costly expenses of the components, we are unable to acquire them to model them for the class. Our pressure relief valves and pressure safety valves usually are priced around $150. Rupture disc prices ranges from $100 to $400. There's a broad range of prices for a pressure indicator from $900 to $3,500 at the high end. The total presentation and material supply cost rounds to $60.
The learning process throughout this project was one of the biggest parts of the actual project, and these are bullets that we have put down to highlight what we feel as the biggest points of the project. The amount of teamwork that went into this project from different aspects and skill sets, and the importance of having correct calculations, supplies, and materials. Amount of safety involved in a project of this size, and that installation would not be an easy task. Designing a virtual system requires as much effort as building the real thing. And if anybody has any questions, please feel free to like, comment below, and subscribe for more.